So in this example, I'm going to show you how we can use the general recipe to find ds for the curved surface of a cylinder. Okay, so we already did it using geometrical intuition earlier, and we found the ds for a cylinder is equal to r d phi dz. And we did it by geometrical intuition. I want to prove to you, or to demonstrate, how to use the general recipe, which is this. Okay, so let's do it. So first of all, we need to write the parametrization of the equation of the surface. Parametrization of the surface. So what we are going to do is we are going to use cylindrical coordinates, but we are to, so let me write it. Use cylindrical coordinates, but fixing rho equals r, the radius of the cylinder. Okay, so then the cylindrical coordinates become r cos phi, r sin phi, and z. Okay, so now this is a parametrization of a surface, and actually it's very easy to understand that our two parameters are theta and z. Okay, so those play the role of what I call u and v in all of the equations. Okay, very good. So now find ds using the recipe. So in an exam, you would go to the list of equations, or you would go to notes if it's an open book exam. So ds is the norm of this cross product du dv. So let's write it, but substituting u to phi and v with z. Okay, so then ds is the norm of partial of r with respect to one of the parameters cross partial of r with respect to the other parameter times the differentials of the two parameters. Okay, so I basically substituted u with phi and v with z. You could maybe ask me about the order. Is it important to write u as phi and v as z, or can I also write z first and phi second? What do you think? Of course it's not important, right? This is just an arbitrary choice of which is the first parameter and which is the second. It won't matter, because what will happen is that by changing the order of the parameters, you will actually change the direction in which the normal vector points, but when you calculate the norm, the direction won't matter, so it will cancel out. Okay, so you shouldn't worry about that. So let's perform this calculation. So first, remember, these are the two tangent vectors in the two directions. Okay, so let's calculate them by doing the partial derivative of r. So doing partial of r with respect to phi. So we do the derivative of this with respect to phi, assuming that z is a constant. So we get minus r sine phi, r cosine phi, and 0. And now we do the partial of r with respect to z, which is like saying that phi is a constant. So the derivative with respect to z will be 0, because this is all a constant, 0 and 1. Okay, so now we do the cross product. dr d phi cross dr dz is equal to x, y, z minus r sine theta, sorry, sine phi, r cosine phi, 0 and 0, 0, 1. So this will be equal to x hat times r cosine phi plus y hat. So let me do it. This is minus I hat this times this, so the minus goes away, and then plus z times 0. So that's it. Okay, so this means that this is equal to this vector r cosine phi, r sine phi, and 0. Okay, so this is the normal vector. Remember, this is now the normal vector to the cylinder. Does it actually make sense that this is the normal vector? Yes, it does make sense. So this vector, if you calculate it for values of rho and phi, sorry, of theta, of z and phi, so for any value of z and phi, you will see that this normal vector is pointing outwards from the cylinder. Okay, so this is indeed the normal vector. Perfect. So now ds is just the norm of that. So the norm of the normal vector is equal to the square root of the first component squared plus the second component squared plus the third component squared, which is 0. Now cosine squared plus sine squared is 0. So therefore this is equal to square root of r squared, which is r. And therefore ds is the norm of n times d phi dz, which is r d phi dz. Okay, so basically I just substituted all of this into the equation that we had for ds. Okay, so those were the steps to calculate ds on the surface of a cylinder, and it worked perfectly, and it agrees with what we got from geometrical intuition. Okay, you see that this was very easy, and you didn't have to be scared with the monster equation of the square root and the different partials and so on. You can just go step by step, calculating the two tangent vectors, doing the cross product, and then calculating the norm. Okay? Excellent. See you in the next video.